Good morning to everyone. Welcome to MNG College. Myself Naina Argoda. So this is a class of continuation for units and dimensions. Let us study about the homogeneity principle. So here we already studied about the dimensions. So here in the textbook you have checking the dimensional constancy of equations. That means the magnitude of the physical quantities may be added together or subtracted from one another only if they have the same dimensions. Means you have the same, if you have the same dimensions, then only you can add or subtract it from each. So either it is differently, you can't do addition or subtraction of the uh, dimensions. Okay, that we call homogeneity. In the mathematical form, LHS is equals to RHS. Means left hand side of a dimension, magnitude of a left hand side of a equation is equals to the magnitude of a dimensional of right hand side equation. Okay, so that we call homogeneity principle. For example, so this is a one of the example is x is equals to x naught plus v naught t plus 1 by 2 a t square. So this is a equation. It tells about for a x is a distance is traveled by a particle or a body in time t, and v naught is a initial velocity v naught at time t is equals to 0, and a is a acceleration due to gravity along the direction of the motion. So let us study about the dimensions of the each term. Okay, so here x is called a distance traveled by a particles. Means distance traveled by a particle means that tells about the dimension of length. So that's why for the x, dimensions for x is L. We have to write in a bracket. Okay, next one is x naught. That means the initial state of a position of a particle. Initial state of a position of a particle means that tells also a length. Means the starting position of a point is L, that tells L. Then what is a V naught? V naught is a velocity of a particle at time t. Okay, so that we call, generally we know that this velocity of a particle is meter per second. So that in the dimensions, meter means L, per second means t to the power of minus 1. Okay, so next one at the time t. So that is t is equals to t. Next, here half is a constant values. So there is no dimensions for the numbers, constant numbers, and a is a acceleration due to gravity at the time t. That is acceleration means L t to the power of minus 2, and time at the time t means t square. So in this case here, so t and t get cancelled. Finally we have L. Here also the t and t get cancelled, means in this the dimensions is same, then only we can add a subtraction of that points or numbers. So here dimensions are same, so that we can means t to the power of minus 2 and addition or subtraction. So here is the plus, so plus. Finally minus 2 plus 2 get cancelled. Here the well. So in this case every term means LHS on the LHS is L. On RHS is for the x naught L, and for V naught t, that means plus L. For the third term is L. So in this case on LHS we have L. Similarly the dimensions on the RHS is L all the terms got L as a dimensions. Okay, so this proves this is the dimensionally correct equation. So this tells dimensionally equation. Okay, so dimensionally correct equation. Similarly, you have another one example. So let us study about the equation, that is of mv square is equals to mgh, means kinetic energy and the potential energy. Let us study about the terms. So what is meant by the m means mass of the body, and v is a velocity, and g is a acceleration due to gravity, and h is a height. Okay, check whether the expression is dimensionally correct or not. Okay, also dimensions of the RHS is m means mass, that is m, and dimensions for velocity is L t to the power of minus 1 whole square. Here is a square, so the dimension of the velocity gets square. So here let us study. So m L to the power of square, this is a multiplication, then only I am writing in the same bracket, then L square, and t to the power of minus 1 into square 2 is t to the power of minus 2. Okay, so this is the equation 1. And next one on the dimensions of RHS is m is mass of the body, that is m, and acceleration due to gravity, that is L t to the power of minus 2. So this I have to calculate, means acceleration due to gravity is L t to the power of minus 2. Velocity of the body is L t to the power of minus 1. And next height. Height means what? That tells about the length L. So simplify it, that is m L into L. So the dimensions is same, then only we can add the power, that is L 2 and t to the power of minus 2. So by the this is the equation 2. From equation 1 and 2 we get LHS is equals to RHS, means that is m L square t to the power of minus 2 is equals to m L square t to the power of minus 2. Okay, so this tells this equation is dimensionally correct. Okay. Okay, so this is another one example that is in a test book, that is example, consider a simple pendulum having a bob attached to a string that oscillates under the action of the force of gravity. Suppose that the period of oscillations of the simple pendulum depends on its length, mass of the bob m, and acceleration due to gravity g. So we have to derive the expression for its time period using method of dimensions. So in this case we have to demonstrate or express the equation for these statements. So generally you know that simple pendulum experiment means, let's take a length of a wire. So that wire is the one end of the wire is attached to the one end, and another one end is connected with a bob. So this is spherical in shape, so this is a bob. When this is oscillate means we have to give some force to oscillate, so till like this is the one end. So when it comes to the one end to the other end and again it's come back to the one position, that we call one oscillation. ಹೀಗೋಗಿ ಮತ್ತೆ ಇಲ್ಲಿಗೆ ಬಂದರೆ, so that we call one oscillations. So one end is attached and another one end is stick to the bob. It is a spherical shaped ball. Okay, so in this case you have to find out the period of time. Means that time period is depends on the length of the wire and acceleration due to gravity. Because of that gravity it oscillates, so that is G. And next one is the what is the mass of the bob. So this is a mass. This bob has some mass. Okay, so here the time period is depends on these three quantities. Okay, so now time period is depends on L, G, M. Okay, so that we can time period is T is directly proportional to L, G, M. So we don't know the dimensional values, so that's why we are giving some values, that is X, Y, Z. So to remove the directly proportional, we have to substitute some proportionality constant, that is T is equals to K L to the power of X, G to the power of Y, and M to the power of Z. Okay, so now let's study about, so K is a dimensionless, means that is a constant, and X, Y, Z are the exponents. Here X, Y, Z, X, Y, Z are exponents, because we don't know the exponents of the dimensions. Okay, let us study means dimensions on LHS and RHS on the both the side. Dimensions means the time period means T. So T have 1, whatever the M and L, so M is 0, L is 0 for the LHS, and that is equals to, in the RHS, L means length, means L to the power X. And next, acceleration due to gravity means minus T to the power, here L have X and so both have power Y, means G to the power of Y. And next one is the mass, that is M to the power Z. So on this basis, in the RHS, that is L, by the addition of a same dimensions, that is L is common, so L to the power X plus Y, and M to the power Z, and T to the power here minus 2Y in the big bracket. So by the similarity on LHS and YHS, or by applying homogeneity principle to this, means you have to equate the equations here. So let equate on LHS and RHS, that is for the exponent of the L is X plus Y is equals to, for the L is equals to 0, and for the M is Z equals to 0, and what is the T? So here T you have minus 2Y on the LHS is equals to 1. So similarly you get Y is equals to 1 by 2 as Y value, and Z is 0. For this, in this case, X plus Y is equals to 0. You have to substitute the value of Y value in this case. Okay, 1 by 2 is equals to 0. Therefore, X equals to 1 by 2. Okay, that tells dimensions of this value. This value, or considered in this case, means T is equals to K L to the power of 1 by 2, means, so there is some values, Y value and the X value. So in this case L have X plus Y x plus y means L is equals to 0, because 1 by 2 minus 1 by 2, that gets 0, and m is a 0. So here, so we can consider that is L to the power 1 by 2, and for the g value is minus 1 by 2 for after all the simplification. So we can write this as k L to the power of 1 by 2, and g will come in the denominator because of the minus 1 by 2, that will get 1 by 2. So therefore t is directly proportional to root of 1 by 2 means root of L by g. So this is the value or relationship between the acceleration time period and the length and acceleration due to gravity. Okay, this k value means k is a proportionality constant, means proportionality constant that have the 2 pi value. So what is the 2 pi value of the bob? Okay, circumference of the 2 pi means circle. Okay, so this is a constant proportionality constant value, that is a 2 pi. So this can also written as t is equals to 2 pi root of L by g. Okay, this is a answer. So up to this ends the clause of units and dimensions.